All right, so this will be the Unit 2A part of the review. So we're going to turn the following decimals into fractions, and we don't need to simplify. So anytime we have a line above the numbers, that tells us that it's going to be repeating. So there are two numbers there, the 2 and the 3, so that's how many 9s we're going to put on the bottom. So this would just be 23 over 99, and that's all you have to do. Where's the next one? We've got 0.415 with the line over it. So the 415 is going to be repeating, that's going to be the top, and on the bottom then, we're just going to put 3 9s, because there's 3 9s there. The next one, we got 0.5 with the bar over it, so that's just one number, so that's just going to be 5 over 9. The next one, we got 0.1708, 1708, 1708, and the little 3 dots there are telling us that's going to be repeating over and over and over again. So we look at the numbers before it kind of cycles over. That's 1708, so this would just be 1708 over 4 9s this time. And the next one, we have 0.155, 155, 155, so there's 3 numbers in this cycle, 155 over 999. So we got 3 numbers there, 3 digits, and then that's going to how many 9s we're going to have, 9, 9, and 9. Sorry about the handwriting. So we're going to use order of operations, PEMDAS there. So the 30 plus 12, that's 42, and of course you can use a calculator in this class, and then 42 minus 6 is 36. 20 minus 12, addition and subtraction, it doesn't really matter, thankfully, if you go left to right, which one's first. So 20 minus 12 is 8, and then 8 plus 6 is going to be 14. Now when we get to multiplication and division like we have, it does matter. I'm going to do the last one in here first, the 10 plus the square root of 36 divided by 2. The square root of 36 is really an exponent. We're looking for a number that times itself is 36, and that's going to be 6. And you can also get that from your calculator. Then we would do division next, so 6 divided by 2 is 3, and then 10 plus 3 is, sorry about the horrible handwriting, 13. Now the next one, right there, the 12 divided by 2 times 5 times 4, divided by all that stuff. Well, we need to do the parentheses first, which is 4. 7 minus 3 is 4, so I'm going to pause it and rewrite everything. And this part is important. We want to do multiplication and division. You have to do it from left to right, so one at a time. So 12 divided by 2 is 6. So that's going to give us 6 times 5 times 4 divided by 4. And then we would do the 6 times 5 next. So that's going to be 30. So we'd have 30 times 4 divided by 4. And then next would be 30 times 4, which is 120. And 120 divided by 4 is going to give us a final answer of 30. And the square root of 300, this should just be 360 here. So let me see if I cross off that 0, color that out. So we want to know if these are rational or irrational. Basically, if the number goes on forever and it's not in a pattern where it's repeating over and over again, it's going to be irrational. So the square root of 21, as I get out my calculator for this, let's see, the square root of 21 is about 4.58257569.5. So you can see that in the calculator. So we'll give that to be an R. The square root of 36 is 6, so that's rational. Anytime you see a line over a number, that means it's going to be rational because we can turn it into a fraction. Basically, a rational number is a number that is stopped somewhere, or if it goes on forever, it's repeating itself over and over and over again. And it's irrational if it goes on forever without a pattern. That's what you got to know. It's irrational if it goes on forever, and everything else in this class is going to be rational. So 13 is rational, stops somewhere. 0 is rational. Negative 3 over 17, that's a fraction already, so it's rational. And then pi would be irrational. It goes on forever without a pattern to it. This last one, we want to figure out if the numbers are natural, whole, integer, rational, or irrational. Just note, it only can be one of these two. It can't be both rational and irrational. That's impossible. So 7, let's go through and just kind of check it off. 7 is rational, negative 8 is rational, 1/9 is rational, and 0 is rational. And then the square root of 2 would be irrational, so we took care of that. And if it's the square root of 2, if it's irrational, it's not going to be anything else. So we'll ignore the stuff for the rest of that. Your natural numbers, you start at 1 and you count, so 1, 2, 3, 4, 5, 6, 7, 8. So 7 would be the only natural number on here. It'll also be a whole number. So whole numbers are 1 through 2, 3, 4, 5, 6, and an integer basically is when you simplify it, there's no decimal, like -4 or +6. So a -8 would be an integer, but wouldn't it be whole because wholes are 1, 2, 3, 4, 5, and wholes are 0, 1, 2, 3, 4, 5, and naturals are 1, 2, 3, 4, 5. Go onward. The 1/9 would just be nothing else there, just rational. 0 would be a whole number and an integer. And I think that's it. So that's going to conclude, hopefully, I got that right, the 2 test review.